Hi everyone, here we are with the second production update on the plinth and progress of the tooling. That's all well underway. The tool design is still ongoing, but that is actually quite a lengthy process and there's 3 distinct stages to it, so we're wading through that. I'll take you inside in a minute and show you the first of the tools, which is now finished the overall layout design and is currently being detailed, so we'll go and have a look at that in a second. Before we do, however, a couple of points. Firstly, there are still about 50 people who haven't yet put in your surveys. Can you do that for me as soon as possible? I'd like to know the addresses and how many plinths we've got to mould and all the rest of it, so I can sort out logistics. Secondly, I'm getting lots of requests from people who want extra products or things being moulded in different colours. I can't make this too complicated at this stage. If you want to order extra products, you will be able to do that. I'm going to set up direct ordering on the MyPlinth website. It'll be ready in time for when the tools are ready. If it works out that way, then I will ship those out with your pledge orders. If it's not possible, then I'll send them to you separately. But don't worry, that will all be set up and made to happen before the tools are finished. For those of you concerned about moving house or your details changing before the tools are ready, again, you will be able to change that on your Kickstarter surveys. You will be able to change your address or update your details right up until just before we ship. And before we ship, I will actually post another update warning people that time is just about to expire. So I will do my best to keep you informed right up to the last minute, but don't panic if you have plans to move house between now and the middle of June. Okay, right, that's about it. Come inside, have a look at the CAD. The first of the tools is laid out, it's quite exciting, and I'm keen to show it to you. Okay, cheers now. Okay, so before we have a look at the first of the 2 tools that will go to make up plinth, let's have a quick crash course on how an injection moulding machine works. This is a fairly typical moulding machine. It's quite a big beast. The injection mould tool itself goes in the middle here and is made up of 2 halves. Okay, there's a fixed half which bolts onto this plate, and then there's a moving half which is moved backwards and forwards by fairly sizable hydraulic rams inside here. Pelletized plastic is poured into the hopper here and is melted into a molten state, ready to be injection molded into the cavity there. Okay, so if we have a look at that as a diagram, you can see here are the 2 halves of the tool, the fixed half here and the moving half here, which will slide backwards and forwards by the clamping unit, the hydraulic rams here. On our tool, of course tools come in all different shapes and sizes, but the tool being used that you're just about to see will be clamped together in a 100-ton machine, so there'll be 100 tons of clamping pressure on these 2 plates here to hold them together, because the pressure of the plastic being squirted in comes in at about 80 to 100 bar, which is about 1500 psi, so it's very, very high pressures here, which means that the tool itself has to be very, very accurately machined. So here it is. Here's the first of the tools. Okay, doesn't look very impressive when you look at it from the outside, but we'll have a look on the inside. Okay, so we have a moving half, so this is the moving half of the tool that will move backwards and forwards, and then you have the fixed half here, which is the half through which the plastic will be injected, so the plastic will come in through here. Okay, if we take the moving half away so that you can see inside, there we get our first glimpse of the actual components for the plinth themselves, and if we hide the other half of the tool as well, you can see the first 4 parts of the plinth. So there's the base plate, the low strut, the high strut, and the little switch that enables you to open it. Okay, now most of the structure of the parts is fairly straightforward, in that all of the line of draw, as it's called, is in the direction that the tool will open and close. So it is just a fairly straightforward mould. However, we have got a feature here where we've got a hole that can't be moulded. So we need some way of getting some metal into here so that we can form this tubular shape here. And the way that's done is using side cores. Okay, so if I now show you the fixed half of the tool, you'll see that the tool designer has added these two angled pins here. Okay, so they don't move at all, they just sit there in the fixed half of the tool. Alright, and then they act on the, so let's hide those now and show you, move over and look at the other half of the tool. Right. So the ends of those pins will engage in these holes here. And what happens is that if you imagine that at the moment the tool is closed, okay, so this is the condition where the plastic is being injected. In order for the thing to be able to, the plastic parts to be able to come out of the mould, we need to move this piece of steel out of the way. So what happens is that as the two halves of the tool open, that angle pin, which is riding in this hole, will make this part, no, that's the wrong bit. No, that's the wrong bit. That's the wrong bit. There. Okay. See that? So this piece of metal can slide inside the tool here. And all of that is to affect this little piece of steel here to go into there and form that tubular hole here. So I hope this gives you a flavour of the complexity of how an injection mould tool is made up. You can see there's a lot of engineering goes into it. This tool that you see here is actually still only partially finished, in that it does not yet have all of the ejection system to actually push the plastic parts out of the moulding, nor does it have the water cooling runways which have to go through all throughout the tool to keep the tool closed, to keep the tool cool whilst the moulding process is going on. There are quite a lot more aspects to this, but I won't baffle you too much with science, but I thought you might like to have a quick look at it at this stage to see how things are coming on. Okay, when we get some more files I will show them to you. I hope you found that interesting, and I'll be in touch soon. Okay, bye.